So what's transfer function for you?
For me, it's love.
Nice.
Tonight we're running on the right track. I know we never gonna look back. Oh, I just wanna have a good time.
It's an experience. Teka, makakaisa sabihin mo. Hi, I'm Chua, and I'm going to be presenting our project, which is designed for a PID controller for heat exchanger. So for a short introduction, the overall objective of a chemical plant is to convert certain raw materials into desired products. So for a chemical plant to be able to successfully convert said raw materials into desired products, it must be arranged in a certain manner, such as it must contain processing units such as boilers, distillation columns, heat exchangers, and many more processing units. So when a plant is under operation, it must be able to work under certain constraints and should satisfy several requirements. The requirements usually vary depending on the operation and specialization of the plant. But the most common requirements that should be satisfied in a chemical plant are safety, product specifications, operational constraints, environmental regulations, and economic considerations. With these requirements known, there arises a need for monitoring the operation of a plant continuously to successfully make sure that all these requirements are met. To continuously monitor the operation of a plant, there is a need for the installation of certain equipment, such as controllers and measuring devices, and humans, such as plant operators and designers, to form a control system. So process control can be seen in multiple chemical plants and industries, such as pharmaceutical, bio-research, and petroleum, to name a few. Now, for chemical plants to successfully convert raw materials into desired products, most of the time, chemical reactions must occur. And for chemical reactions to occur, heat is needed. For heat to be able to flow properly within the plant or a system, a device called a heat exchanger must be used. A heat exchanger is a device that is used to transfer heat between a solid object and a fluid, or between two fluids. Heat transfer is typically an efficient process, although maintaining the temperature of the fluid that is being heated may prove to be quite difficult. By applying process control within these heat exchangers, can we properly observe and maintain temperature at a certain set point. Now, there are also different types of control schemes that may be integrated within a heat exchanger, such as cascade, feed-forward, and feedback control schemes. The choice of the control scheme depends on the design of the system and variables that are currently present within the heat exchanger.
So continuing on what Mike said, so this design project is going to be about using the concepts and theories of process control and applying it to chemical engineering. So one of the most abundant unit process that is used in chemical engineering is the use of heat exchangers. This is used for acquiring the desired temperature of for a flowing fluid. So for the main concept for a heat exchanger is hot fluid goes in one side, and then a cold fluid goes in at the other, and then it comes out at a new temperature, different from its initial, and then this one also comes out. So it's basically just transferring heat from one another. So we're going to be designing a PID controller for a simple double pipe heat exchanger.
I'm Neil, and I'm going to discuss the system that we will consider in this project. So the system that we consider in this project is a double pipe heat exchanger where two streams enter the tube. One is the hot water and the other one is the cold water. Since the temperature of the water that exits the heat exchanger is not constant, a sensor will be used to control the valve that controls the flow of the hot water. So in this project, the transfer function of the temperature sensor and the valve is set to unity. So this is the closed loop block flow diagram showing all the transfer functions in this system. So in this project, Kc was set to 1. And this is the transfer function of the heat exchanger. This is the dead time, and this is the transfer function of the final control element.
Mendoza, and I'm here to demonstrate our MATLAB program for a simple double pipe heat exchanger. Come on.
So our program is fairly simple. So it first starts off with the Kc, then it asks you to input a value of Kc, Then this would then be entered into the numerator program for the proportional control, in which the denominator c is set to 1, and then GC transfer function is just the numerator over the denominator. Then proceeding on to the transfer function for the heat exchanger. So it was discussed earlier that it was a first order transfer function. So the numerator is just 0.6, and then the denominator is 1 for 20 s squared plus 1. And finally, we make it a transfer function to transfer function num h dh. However, there is actually a dead time of e raised to the negative 40. So we call the input delay function, then set it to 4. Then finally, we place the overall forward transfer function as G4 as the series of GC, which is the controller, and the transfer function of the heat exchanger. So moving on down, we actually assumed our GM for the final control valve to be 1, approaching unity. So it's just numerator 1 and denominator 1, GM transfer function num and denominator, and then the feedback transfer function would be set as G4 and the G back. And finally, we will look at the step response of this. So after that is done, we will then proceed to the PID controller after we have determined the ultimate gain from the P controller program. So the PID control is just the same. We just turned off the proportional control program part. Then we activated the inputs for TI and TD for the time integral and time derivative variables. Then we turned on our PID controller, which is for the numerator. This is the transfer function for the PID controller. So this time the GC is the transfer function of KC times TI. The numerator is KC times TID times D, then plus TI plus 1 all over TI S squared. So the same, the transfer function for the heat exchanger is the same with the dead time, the forward, the GM, and then the backward, and then we will simulate the step response of this function.
I will be showing how to run the MATLAB program. So first, when we run the program, it prompts us to input the value of Kc. So first, if we input the value of Kc, this is the step response. This is the graph of the step response. Then, after multiple testing, if we input the value of 14.1705, this is the step response of the new graph. Then after that, using the Zn parameter for tuning, we input the Kc value of 8.3356, time derivative of 7.45 and 1.8625. This is the Zn tune PID controller parameter, and from this graph you can see that it isn't smoothed out. However, if we lower the time derivative, the new graph will look like this, which is smoothened out.
Yeah.
So that's all. Thank you, sir. So again, sir, thank you for all the things you taught us in process control. It really opened our eyes to the broader perspective of what we as chemical engineers do. Thank you again, sir.
Bye.
Bye.
See you next time.
Time, call me when